All right. All right, here is our Unit 5 study guide on trigonometry. All right, this is due the day of the test, which is Tuesday. Okay, so for 1 and 2, we are graphing our trig functions that have been transformed, and we need to, part A, state the period, and then we need to draw the graph and clearly label our x-intercepts and the y-axis so that, I don't know how to spell it, to show the maximum and minimum values of y. And so this maximum and minimum values of y really just applies to number 2 because of our sine function. Whereas the x-intercepts part really refers to our tangent. All right, so let's begin with our tangent function. So what we have to remember about our tangent function is what is the original period. So the original period of the tangent function is pi. And then when your function has been transformed, what you do is you take that period and you divide by that coefficient of your x inside the parentheses. So this period is pi over 2. Then, because it's tangent, what we need to do is, because of this transformation right here, we need to find where the new asymptotes are. So the original asymptotes on the tangent function, so maybe like over here. So the OG asymptotes are at pi halves and 3 pi halves. So our asymptotes are going to change. So how we find our new asymptotes, is that we take our asymptotes, the original ones, and we set it equal to whatever is inside the parentheses there. Okay, so I'm going to take pi over 2 and I'm going to set it equal to 2x. So it's not that it's always equal to 2x, and I know that's what I made it seem like in class today when I wrote those notes on the board, but it's whatever is equal or whatever is inside those parentheses. So then I'm going to divide both sides by 2 or multiply by 1/2. And I get pi over 4 for my first asymptote. So then I can do it again over here. And so for my second asymptote, I have 3 pi over 2. And again, I'm going to set it equal to whatever is inside my parentheses. Now, if something was added or subtracted, I would also put that over here as well. So again, to solve for x, times by 1/2. And I get 3 pi over 4. So these are my 2 new asymptotes, which is going to help us with our table. So when we graph. Okay. All right. So next thing we want to do is we want to determine our interval, and that helps us with our table. Okay. So our interval is always your period divided by 4. And this applies to sine, cosine, and tangent. It's always the period on top, your new one, after the transformation, and it's always the number 4, okay? So ours is going to look like pi over 2 divided by 4. Now remember, we can keep, change, flip, or multiply by the reciprocal, and that's going to be pi halves times 1/4, which is going to be an interval of pi 8. Now, this pi 8 is, again, helping us graph, helping us with our table. The table is not required by any means. I just cannot graph without it. So I'm going to do a table. So again, this just means I'm going to add pi 8s each time to find my next x-intercept. Okay, I'm kind of running out of space over here. So, and I don't want it to be squished, but I'm going to do this. Okay, so for my table, I'm going to start with x and y. All right, so my interval is from 0 to 360. So I also want to know what the ordered pair is at 0. Okay, so when x is 0, my graph has not shifted up or down, and it has not shifted left or right. So this is still going to be 0, or you could just plug it in. 2 times 0 is 0. And then when we calculate tangent of 0, you may use your calculator or your unit circle, and tangent of 0 is, in fact, 0. So I'm going to begin with my vertical asymptote, okay? So my first vertical asymptote is pi over 4. So this is where I begin my pattern, Okay, and I know this is my vertical asymptote, and then I'm going to stop when I get to my second vertical asymptote, which is going to be 3 pi over 4. So then again, remember, my interval is pi 8. So I'm going to start at pi over 4, which, if I convert to a denominator of 8, is 2 pi over 8. So again, when I add pi 8s, this one's going to be 3 pi over 8. And again, sometimes they can be reduced and simplified, and sometimes they can't. Like that one can't be. So then I'm going to add pi over 8, and this one's going to be 4 pi over 8. Okay. So here, let me do this. Plus pi over 8. And then this one is 4 pi over 8, which we know to be pi halves. Plus pi over 8. So the next one's going to be 5 pi over 8. And then the next one is 6 pi over 8, which is 3 pi over 4. And look at that. That's what I want. That's my other vertical asymptote. So remember, tangent has a pattern, and it's going to repeat its pattern between the vertical asymptotes. We discussed today that halfway between the vertical asymptote is your x-intercept. So again, 1, 2, 3, 4, 5. We talked about that today as well, how it's a list of 5, like number 5 is always your vertical asymptote if you forget or choose not to find that second vertical asymptote. All right, so again, we begin and end at an asymptote. Right in the middle is our x-intercept. Then remembering the shape of the parent function. So like if I come up here, the shape of my parent function of tangent is that it's going to start down and curve up, start down and curve up. So like when you read our graph from left to right, it's going to hit that -1 value, and it's 1 because that's a part of the parent function. It's going to hit that -1 value before it hits the +1 value. So our pattern in our table is going to be -1 and 1. Keep in mind that these two numbers will change if you have a vertical or horizontal shift in here. Okay, so now it is time to graph. So this is what I put on my x-axis, but remember, again, we're coming all the way here to 360. So you can see that I did this in radians. It just made things a little bit easier, and there's less decimals and crazy things. So like I'm gonna graph my vertical asymptote, I'm gonna graph my x-intercept, and then my vertical asymptote. And those are going to be the 3 things I graph. So I'm just going to scale my x-axis using these 3 parts, or these 3 terms. Okay, so that way you can still see the table. All right, so my graph, again, I'm going all the way to 360. This is my y-axis, this is my x-axis, this is 0. So like the instruction told you to clearly label. So like please make sure you go above and beyond to label your graph. All right, we know that at 0, 0, that's where my graph is starting. My first vertical asymptote is pi over 4. So remember, pi is equal to 180. So that's 180 divided by 4. So I can put it in degrees on my x-axis. So my first spot that I'm going to label is pi fourths, or 45, and then 90, and then let's see, 3 pi over 4, so that's 3 times 180 divided by 2, that's 270, and then 360, okay? So I'm going to have, wait, that's not an even scale. So sorry. Because that's a difference of 45. So a difference of 45 here is 135. Sorry. And then plus that last 45 will be, wow, I skipped right over 180. How did I even do that? Okay. Plus 45 again is 225. All right, and then plus 45 270, and then 360 for that last spot. Okay. It's 350. Okie dokie. All right, so let's graph. Okay, I know my vertical asymptote is going to happen at the 45s. So at 45 and 3 pi over 4. So remember, 3 pi over 4 was 135. So basically every other tick mark is where I'm going to have a asymptote. And again, remember, this is a pattern, so it's going to repeat. All right, so again, I didn't have a vertical or horizontal shift. Oh, that's probably more like right there. All right, so remember what the original parent function looks like. So this is the shape we will emulate over here between my asymptotes. So it's going to come up. And this value, right, this value right here is like this weird decimal that we get for these two values in our table. Okay, so again, at pi halves, which is 90, I'm going to be 0, so it's going to clearly label, it says, so I'm going to make sure it's a solid dot there. And then at each y value of 1 and -1, I want to go ahead and put a point there. Okay, just to be extra safe. So again, our table stopped at 135, but I know that my pattern's just going to continue to repeat, okay? All right, so here is our graph for number 1. Pause if you need to, anytime, okay? I'm just gonna keep on rolling. All right, number 2, this is sine, so this one is graphed a little bit differently, but we're still gonna start with our period. The period of the original sine function is 2 pi, and then again, we divide it by that b value, which is the coefficient of our x. Keep change flip turns it into 2 pi times 2, which is 4 pi, okay? All right, so with sine and cosine, you want to find your midline and your amplitude. So your midline is your vertical shift, and that's always a y equals. That's what number is being added or subtracted to your sine function. Your amplitude helps find your maximum and minimum. It is the coefficient of your sine. Okay, and in this case, that number is 1. All right, we're still also going to do our interval here. I guess I didn't really need to do it right there. All right, so my interval is still my pi divided by 4 every time. Again, it's always period. Sorry, I said pi. Period. It's your period divided by 4, always divided by 4. Doesn't matter if it's sine, cosine, or tangent. Oh, excuse me. So that equals pi. All right, again, also you need to be familiar with the parent graph of sine. The parent graph of sine is going to start at the origin and come down and up and down and up and down and up, okay? So when we do our table, again, going from 0 to 360, I'm going to start at 0, and then my interval is pi. So I'm just going to add pi each time, pi, and then 2 pi, which is 360. So I can stop right there. All right, because this graph was shifted up 3 units, okay? There was no horizontal shift. Because it was shifted up 3 units, instead of starting at 0, 0, it's starting at 0, 3. And if you are uncertain or not convinced, you may always do direct substitution. You may take this 0 and plug it in right here and find sine of 0, which will produce 0, and then add 3 to that, okay? Now remember, your generic shape of your sine function, because it is not reflected, okay? Your parent function means from that origin, it's going to go up, all right? So it's going to go up by my amplitude. So it's going to go up 1 unit. So up 1 from 3 gives me 4. That's going to be my max. Then it's going to come back down. So it's going to come down 1 because of my amplitude to be 3. All right, so let's do that graph. This graph is going to look really strange because of the interval. Again, make sure you label, oh, I shouldn't do that. Make sure you label properly as best you can. Again, this one's not going to have any x-intercepts, but this one's going to have a max and min of our y, so it wants us to make sure we clearly label that. So 1, 2, 3, 4. So I know my graph is going to go up to 4. Okay, its midline is 3. So I'm going to take my 3 and draw my midline. Okay, again, these are like my boundaries for my graph. Okay, that's my max. Again, my midline came from my vertical shift. The going up 1 and down 1 came from my amplitude, which is my coefficient of my x. Of my sine, okay, or my cosine, depending on what it is. All right, so 0 and then pi, which is 180. So let's make sure here. I'm going to do my max is 360, and then like halfway is going to be 180. All right, so at 0, we're at 3, so I'm going to go ahead and label that. And then at pi, remember, we're going up, so that's 180. So at 180, I'm coming up, and then at 360, I'm coming back down, but that's as far as we go. We stop there. So this is like a quarter of a period. So this is our picture for number 2. All right, number 3 says use the function in number 2 to find the least positive value of x that gives the maximum y, and the least positive value of x that gives the minimum value of y. So what it's asking graphically is which x values give us a maximum y value and which x value give us a minimum y value. And I want these x values to be positive, okay? So I broke it down like this. Where is the max? Well, my max, if we look at our picture, our max is a y equals 4. Well, what x value does that happen at? Well, here's the max. That x value is 180. Is that the smallest on this interval? Yes, it does not hit 4 anywhere else. So this is the least positive value of x that gives a maximum value of y. So this is that first part. Now for the minimum. Okay, look at my graph. The minimum y value is 3. I want to know, okay, what x value does that happen at? Okay, well, it happens in 2 spots. It happens right here at 0, and then happens again right here at 360. But remember, we want the least positive. Okay, between 0 and 360, 0 is clearly the least number, but is 0 positive? No, 0 doesn't have a positive or negative, it's neutral. So 0 is an invalid answer choice, and 360 is our final answer for the least positive value of x that gives a minimum value of y. All right, number 4. The function is defined such as this: a plus b sine x. For the interval 0 to 360, a and b are positive constant. Find a and b and write the function. So it's 2 parts. Find a and b and write the function if the max is 8 and the min is -4. So I'm a very visual person. So what I did, so this is a sine function. Okay, so it's going to look pretty similar to this. We're having a midline, we're having a max, we're having a min. All right, so this looks like this. All right, we have a max of 8, and we have a min of -4. So I need to find, well, where is the middle? Because that's going to be my midline or my A, my vertical shift. Okay, so from +8 to -4 is a distance of 12. So I'm going to take 12 divided by 2 to find the middle, and that means 6 is my middle, which means, okay, well, here, let me choose a different color. So which means that I'm going to go 6 down, and I'm going to go 6 up. Okay, so I said that was A. That's not going to find your vertical shift. That's going to find your B. It's going to find your amplitude. All right, so this 6, again, represents 6 units up and 6 units down. So that means my amplitude, is equal to 6, which in this equation that they gave us is the letter B. So now I have to know, like, well, what is this y value right here? Okay, well, there's a couple different ways you could do it. I chose to do -4 plus 6. You could do 8 minus 6. Either way, you'll get the same answer. So from -4 to +6, if I start at -4 and go up 6, I will get 2. So y equals 2 is going to be my midline, which is, if I knew how to spell, this is equal to our A value. So sorry, that's kind of janky. A is equal to 2. All right, so then we need to write the function. So we'll just take our A and our B value and plug it into this equation. So f of x, our A is 2 plus our B is 6 sine x. So kind of a two-parter. We have an A value and we have a B value. All right, so we're going to use this function now and we're going to solve. Okay, so I'm going to rewrite it. It says solve the equation f of x equals 0 on 0 to 360. So my function was 2 plus 6 sine x. And then I'm going to set it equal to 0. So remember, this we're just using like a variable situation here. And we want to solve for sine of x. So I'm going to move my 2 over and then divide by 6. Move my 2 over, divide by 6. I want to reduce this. All right, our interval is 0 to 360. So at this point, I'm drawing my x and y axis right here. All students trust Cambridge. Where is sine negative? Well, sine is going to be negative here and here. Both of those are in my interval. I'm doing okay. So now I'm going to grab my calculator and make sure it is in degree mode. Okay, I'm going to grab my calculator. It's in degree mode. And I'm going to do second sine to get my inverse so that I can solve for x, negative 1/3. So negative 19.471. Okay, so remember that negative number in terms of this means that I'm moving clockwise. But this number also needs to be in this interval, and it is not. So in order for us to put this number in the interval, okay, I need to add 360 to it. So this, remember, is still this angle right here between the x-axis and our segment, but I'm going that way. I'm going clockwise. That's why it's negative. And that's a problem because that's not on my interval. So to fix that, I add 360 to it. So if I start here and add 360 to that negative value, it will give me this angle that I want in that fourth quadrant. So I still have it up, so I'm going to do 360 plus that answer. And this is going to be where that angle is in the fourth quadrant. Rounding to 3 significant figures, I get 340.5. All right, so that's my first solution, but I also know that I have a solution over here in the third quadrant. And remember, that angle between this segment and the x-axis is still 19.471. So to get that measure, I need to do 180 plus 19.471. And it's positive, again, because that negative simply just was telling us what direction we were going. All right, right here, that's going to give me 199.5. All right, 2 quadrants, 2 solutions. All right, number 5 is another graphing one. Find the period, sketch the graph. All right, so this is cosine. So my period begins at 2 pi. I divide it by the coefficient of my x, which is 2. My new period is 5. My midline, because it's a cosine, is y equals 1. And then my amplitude is 3, which means I go up 3 from 1 and down 3 from 1. Then for my interval, I take my new period and I divide it by 4. All right, so I'm going to set up my table. Sorry, that's an ugly X. All right, I'm doing it from 0 to 2 pi, so now I'm in radians. So I'm going to start at 0, but remember we are shifted up. Okay, and we're going to plug it in. So 2 times 0 is 0, but cosine of 0 is 1. 3 times 1 is 3, plus 1 is 4. Okay, so again, please make sure that when you're solving for that y-intercept, that you like plug it in all the way if you're doing the table. Okay. All right, so then I'm going to add pi fourths to that, and then add another pi fourths, which is, that's 1, so that's 2 pi over 4, which is pi halves, and then 3 pi over 4, and then 4 pi over 4, which is equal to pi. And then there's my period right here. From 0 to pi is 1 period. So I can stop because I know even though my interval goes all the way to 2 pi, I don't need to go all the way to 2 pi in my table because once I have 1 period, it's just going to repeat the same pattern. All right. So this graph is not flipped over at all. So we need to remember our parent function for cosine. Cosine, okay, goes down when it starts. Okay, cosine goes down and then up. All right, so remember, midline is 1. I went up 3, there's my 4. So I'm going to come down after that. So again, my cosine, my original cosine function is going to start here and go down, up, down, up, down, up. So it's starting here at 4 and coming down. So I'm going to come down 3, make it to 1. And then I'm going to come down 3 more because 1 is my midline. So I got to come down 3 more. Down 3 more gives me the -2. No, that's my min. So here's your max. Here's your midline. Here's your min. And then I'm going to bounce back up. So I'm going to go back to my midline, back to my max. Okay, make sure we label everything good. I'm going to use my table and just go up by pi fourths. Okay, this one's going to be 6 pi. Remember, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. 5 pi over 4, 6 pi over 4. 7 pi over 4, 8 pi over 4. Okay, I guess I made it a little long, sorry. All right, so let's do... All right, so my midline right here is at 1. Go up 3, 2, 3, 4. Down 3, 1, 2, 3 down here at -2. All right, so I'm going to start up here, and then my first stop is going to be down here, and then I'm going to keep going down, and then I'm going to bounce back up. So again, no, you do not have to do the table. I like the table, but it's not required, especially if you know the shape, okay? All right, so we're going to come down, we're going to come back up, we're going to come down, we're going to come back up. All right, how many values of x does y equal 0? So this is looking for an x-intercept. How many times does it cross the x-axis? Well, 1, 2, 3, 4. What is the smallest positive value when y is equal to 0? So what it's asking you to do is solve. That's what it's asking, Okay, so, oh, sorry. So you're gonna solve, and then there's gonna be lots of answers on this one, but it wants the smallest one, and it wants the smallest positive one. So you just wanna take your smallest positive answer, all right? So 3 cosine, AKA your first answer. Subtract the 1, divide by 3. Oops. Okay. Typically right here, we would let our u equal to this. I will still do it, but we do not need to manipulate our interval because we are only looking at the smallest thing. Okay, so I'm still going to do it so that you can practice, but we're not going to change anything. It's not going to affect how we answer. All right, so remember, this would cause my interval to turn from 0 to 4 pi, which is going to give us 4 solutions. Wait, no, that's going to give us 8 solutions. Okay, you're going to have... Either way, we only want the first one. All right, so now we have cosine of u equals negative 1/3. We don't even need to do our axis or anything like that. I got to put my calculator back in radians because of that 2 pi. Inverse cosine of negative 1/3 is this. And so then that is our u value. So u is equal to 1.9106. All right, but remember we let u equal to x. So 1.9106 is equal to 2x. So I'm going to take that, divide by 2, and then this is my answer. So 0.9553. Oh, I went too many, sorry. 3 significant figures would be this. All right, because again, I wanted the smallest one, so we don't have to go through the whole gamut of finding all of the many, many solutions. All right, number 6. What are the maximum and minimum values of h? Okay, so this is cosine. Again, what it's looking for are these boundaries. What is this maximum? What is that minimum? So again, I'm very visual. I'm going to draw a little graph here to represent these values. All right, so my midline is y equals 3. My amplitude is 2. Again, that negative is just a reflection over the x-axis. It's not going to change the max and the min, okay? So I'm going to draw a little graph. All right, my midline is 3, 1, 2, 3. So here's my midline. Then I'm going to go up 2 to 5 and down 2 to 1. Okay, so this means that my max value is equal to 5 and my min value is equal to 1. All right, now we're going to take this equation right here and we're going to solve. All right, so we're solving for when h of x is equal to 2. So let's come over here and do 3 minus 2 cosine x equals 2. All right, my interval is from 0 to 2 pi, so that means I know I'm in radians. So let's isolate cosine. I'm going to subtract 3 and divide by negative 2. Okay, when I subtract 3, I get negative 1. When I divide by negative 2, I get a positive 1/2. All right, now I need to draw this little guy, and I need to figure out, well, where is cosine positive on the interval from 0 to 2 pi? So all students trust Cambridge. Cosine is positive here and here, so we're going to have 2 solutions. Now, if you know your unit circle well, you will know that 1/2 is on your unit circle. Okay, so like right here, cosine is our x value, like 1/2 is there. It's not just some like gonna be weird decimal thing, which means that you can have 2 types of answers. You may have a radian answer with a pi in it, or you may have a decimal answer. It will allow, or it will accept either of the answers is what I'm trying to say. Okay, so I'm gonna grab my calculator. I'm in radian mode, so inverse cosine of positive 1/2 gives me this big guy. So x is equal to 1.0472. So again, when you are like initially working through your problem, please don't round. Okay, so again, this is my angle. So my first angle right here in the first quadrant is that 1.0472, okay, which is pi-thirds. Again, either answer will be accepted. Okay, so either answer is fine. Okay, that's our first one. Now to get this one, I need to start at 0, go all the way around to this spot right here. Okay, and again, remember, this angle is the same. This is still 1.0472. So I'm going to do my 2 pi, because I'm in radians, minus that piece. So 2 pi minus the 1.0472. Okay, so 2 pi minus that. 5.24 rounding, or using your unit circle, 5 pi thirds. So I'll show you on the unit circle real quick. All right, we were looking for where is cosine equal to 1/2. So remember, cosine is your x coordinate. So I know I have a solution here in this quadrant, and I have a solution here. So I'm looking at my x quadrant. Where does x equal 1/2? Not my x quadrant, my x coordinate. So right here, this is how I got my pi thirds. Okay. And then for my other one, again, I'm going to look at my x coordinate. Here is the other spot where my x coordinate is equal to 1/2, and that is 5 pi over 3. 5 pi over 3. All right, again, either answer will be accepted. All right, now we're solving from 0 to 720, which is technically 2 rotations. But if you see right here, that 1/2 is going to affect that domain, that interval. All right, so let's solve. So 4 sine 1/2 x plus 3. I'm going to move my 3 over and divide by 4. All right, so I need to fix this. I can't have this in here. So I'm going to do a little substitution, and I'm going to say let u equal to 1/2 x, which means I have to 1/2 my interval. All right, so my 0 doesn't change, but that changes to 360. Okay, so I'm just looking at one rotation. All right, over here, I'm just looking at one rotation where sine is negative, because remember, this is sine of u equals -3/4. Okay, so sine, all students trust Cambridge. Sine is going to be negative here and here. Again, if you are struggling, how do I know where sine is negative? Write down the signs of each quadrant. Like this is positive, positive. This is negative, positive. This is negative, negative. This is positive, negative. And remember that on the unit circle, cosine is your x coordinate and sine is your y coordinate. Okay, so that's how I'm doing that. All right, back in degrees. All right, inverse sine of -3/4. Okay, -45. I'm sorry, 48.59. All right, so u -48.5904. All right, a little red flag should pop up. This is not in our interval from 0 to 360, so I need to put it in my interval again. That's that 38, I'm sorry, the 48 is still that degree right here, but it's just going in the wrong direction. All right, so we're gonna have to add 360 to this to get it into the interval, and we end up with 311.409. All right, so this is gonna be one of my first ones, but again, remember I did this little ditty right here, so I'm gonna have to go back and solve for x later. All right, to get into my third quadrant, again, this angle is still that 48.5904, so I'm gonna do 180 plus that to get the next one. That's going to give us 228.5903. So now I need to take my two solutions, set them equal to 1/2 x so that I can solve for x. So 311, 409 equals 1/2 x. And 228.5903 equals 1/2 x. Multiply by 2, this one gets 622.8 and 457.2. And again, now you can see these two numbers aren't in this interval, but they are in this one. Okay, so just because it's a bigger interval doesn't mean there's going to be more solutions. Okay, sometimes that does happen, but sometimes it doesn't. All right, this one. Okay, this one might feel a little new and weird. I don't believe we got a chance to get to something like this, but not a whole lot changes on this one. All right, 0 to 180. The only thing that's going to be weird is right here, but we're still doing this same concept to our interval, except for instead of just having this, we also have to add the 25. So like we will multiply our interval by 2 and add 25 because of what's happening inside. All right. All right. I'm going to divide both sides by 2. Okay, then I'm going to let u equal all of this. And again, I have to adjust my interval. So I started out as 0 and 180. So I'm going to multiply by 2 and add 25. So 0 times 2 is 0 plus 25 is going to start at 25 degrees. And then 360 plus 25 is going to end me at 385. So the only thing I have to do is just make sure that when I do my inverse right here and I get this number, if this number's not in my new interval, then I adjust. If it is, it's fine. I don't have to change anything. So sometimes this, fixing this means extra work for you, and sometimes it doesn't. All right, so now I have cosine of u equals square root 3 over 2. We're in degrees. Again, where is cosine positive? Okay, cosine is going to be positive here and here. And again, if you're familiar with your unit circle, this value is on the unit circle. All right, if you're not, grab your calculator and you do inverse cosine of square root 3. Get out from underneath the radical, divided by 2. Close your parentheses. All right, so it's going to give you 30. So if you had your unit circle, you would also see that as well. So u is going to equal 30. So we have a little 30-degree turn right here. Well, that satisfies one of my solutions, and now I just need to find my other solution in that fourth quadrant. Okay, remember we're starting at 0. We're going to go all the way around this way. So to get that solution in the fourth quadrant, I need to do 360 minus 30. Okay, and again, I'm focusing right here. I'm not paying attention to this right now, except for just making sure these u values lie in between those numbers. Okay. All right, so I have 2 u values right here, but remember I adjusted, so I have to set both of these things equal to that. All right, so that's going to give me 30 equals 2x plus 25. Subtract 25, you get 5. 2.5 is what x is equal to. It's probably not in degrees. So x is equal to 2.5. And then 330 equals 2x plus 25. This also is going to give you a decimal, 152.5. And I would assume that the fractional version of that would be accepted as well, but I have mine as decimals. All right, number 9 is one of those proving ones where you have to rearrange, but this time it looks a little funky. So it gives you like 2 full equations. So like we need to take all of this right here and make it look like that. Okay, so we're not just going to focus on one side this time because they gave us 2 full equations. On some of the other ones, if you look, like on the next page, right here, we have, first of all, we have these 3 bars right here, and there's only 2 sides. Okay, there's not like 2 whole equations. So that's why, that's why this one is different. All right, don't let this overwhelm you, okay? It's not that bad. At first, it seems uber scary, but it's not too shabby. Don't forget about your trig identities. You will be allowed to use that Pure One Math reference sheet or formula sheet, whatever it's called, that I provided to you. As long as you're not adding anything to that reference sheet, you are more than welcome to use it on the test, and those trig identities are on that. All right, so I'm going to multiply both sides by tangent so that I can get rid of this denominator. So that's going to cancel out that denominator. This turns into 2 tangent squared x. Oh, I forgot my plus 1, sorry. Plus 1 equals sine squared x plus cosine squared x. All right, right here, you should recognize this as an identity. That's going to equal 1. Oh, okay. Sorry. Reverse. All right. This tangent needs to be distributed to both of those terms. So this first term gave us the 2 tan squared x, and then I have to multiply tangent by that. Sorry about that. So plus, all right, 2 tan squared x plus 1 tan x. Okay, sorry. All right. Now here we are. All right, see, look, it's already starting to look like what we want it to. All right, there's the 2 tan squared x, there's the plus tan, and then this minus 1 comes from taking my sine squared plus cosine squared, turning it into 1, and then moving it over. So I'm going to replace this with a 1, and then I'm going to subtract it. So I'm left with 2 tangent squared x plus tangent x minus 1 equals 0. And that is what we needed to get to. Okay? All right, next, it wants us to solve that. Okay, so it gave us the ugly version. Remember, we already found the pretty version. So let's use the pretty version to solve. Okay? So my pretty version was 2 tan squared x plus tan x minus 1 equals 0. All right, we are solving for the interval 0 to 360. So please remember that this is looking like a quadratic, okay? So we will go ahead and let right here y, or whatever letter you want, equal to tan. This time we do not have to alter our interval, okay, because we're just doing a little fancy substitution. So that's going to turn into 2y squared plus y minus 1 equals 0. And now we have to factor. So I'm going to slip and slide, and this becomes y squared plus y minus 2. Factors of -2 that add to 1 will be a +2 and a -1. But I have to make sure I don't forget the fact that I multiplied things by 2, so I have to undo that. If it reduces, then I'm going to use that new value. If it does not, I'm going to slide that denominator in front of my variable. Now I'm going to go ahead and replace my y's with tangent. So I have a tangent of y plus 1 and 2 tangent of y minus 1. Again, because we're set equal to 0, I need to solve just like I would have solved when I got to this step. So I'm going to take both of these, set them equal to 0. Okay, so I'm going to come up here, and tangent of y plus 1 equals 0. Tangent of y equals -1. All right, I'm solving. So I'm going to draw this. All students trust Cambridge. Where is tangent negative? Well, tangent negative is here and here. So make sure I'm in degree mode. Inverse tan of -1 gives me -45. So y is equal to -45. But hey, guess what? It's now on my interval. So I got to add 360 to it, and that will give me this angle in this quadrant. So again, remember, that's still a 45-degree turn right there, just in the wrong direction. So I'm going to add 360 to that. Whoops. And we get 315. So that's going to be one of my first solutions. Okay, and then to get the to get the solution in the second quadrant, I need to do 180 minus that 45. So 180 minus that 45 will give me 135. All right, now I need to repeat this process with this second binomial over here. So we took care of the first one. That was a tangent of y plus 1. Check, we've done that one. Now we need to do this second one. All right, so I'm gonna put a little line to kind of separate. So we're gonna do 2 tangent of y minus 1 equals 0. Add the 1, divide by 2. All right, I'm looking for where is tangent positive. Here and here, so inverse tan of positive 1/2 is this fancy little number. So y is equal to 26.565. And again, that's going to be one of my solutions. So that's that angle. Well, to get this quadrant's angle, I need to go all the way around plus that. I'm sorry, halfway around plus that. So 180 plus my 26.565. 206. Okay, and there are your final 4 solutions. All right, we're getting there. All right, some more proving. All right, we need to take this side and make it look like that side. All right, this, okay, sorry. I'm gonna have to go quick. My phone's about to die. All right, let's fix tangent first. All right, so cosine of theta is gonna turn into sine over cosine times 1 minus sine theta. I would encourage you to try and write it in such a way where you understand that 1 minus sine is in the numerator and is going to stay with the sine instead of the cosine. All right, I'm going to keep change flip all of this. Okay, I'm going to keep change flip all of this, leave my cosine out over here. So keep change, I'm going to flip both of these things. So it's going to become a cosine theta over sine and 1 over 1 minus sine theta. So I kind of split it up into 2 fractions right there. You are not required to do that. It just helped my brain. It made more sense to me. So I'm going to leave this alone, and then I'm going to actually multiply those 2 things together. So this gives me cosine squared. I tried not to multiply too much, but and leave some of it in factored form, because usually that means you're going to cancel it out eventually. All right, right here, this is a trig identity. So I'm going to replace this big guy, and that's going to turn into 1 minus sine squared theta over sine 1 minus sine. All right, so we should recognize this numerator as a difference of perfect squares. All right, so then that turns into 1 plus sine theta times 1 minus sine theta. And this is why I didn't this is why I didn't distribute in that denominator. Because otherwise, I would have probably factored it and then had to undistribute. You know, I would have had to undo it. All right, these 2 things are going to cancel. Leave us with 1 plus sine over sine. So if you notice in the initial problem, I have 2 things. I have 2 terms. So let's split it up. So this would be 1 over sine theta plus sine theta over sine theta. Well, anytime the numerator and the denominator are the same, that turns into a 1. So 1 over sine theta plus 1. And it's okay that these 2 terms are flipped from that one. The commutative property is understood and implied, and it's okay that it's not like 100% identical. All right, so now we want to solve it. So of course they give us the ugly version. Well, don't use the ugly version, use the pretty version. All right, so I'm going to take that and set it equal to 0. 1 over sine theta plus 1 equals 4. Okay, we're solving from 0 to 2 pi. Subtract the 1. Multiply both sides by sine. Oops. Divide by 3. All right, so now I'm looking for where is sine positive? Here and here, okay? So I'm going to make sure I'm back in radians and inverse sine of 1/3. Okay, this is gonna be my first angle. All right, so this is my first angle. I didn't have to do any funky substitutions, so that's gonna be one answer. And then to get the answer in that second quadrant, remember I gotta do 180 minus that little piece. So because we're in radians, it's gonna be pi minus this. And that's gonna give me rounded 2.80. All right, almost there. All right, new problem. They want us to kind of rearrange it. So they want us to take this thing and put it in this form. So we want to get just one sine squared term and then something being added or subtracted. So remember, this doesn't mean that it has to be a positive. All right, so I want to convert everything to sine. So I'm going to change out that cosine squared. Okay, so right now we're just kind of like simplifying and rearranging. Now I need to distribute. Combine my like terms right here and right here. Okay, look at this, look at this. We want to put the constant first and then the sign second. So I'm going to move my -4 up to the front. And then 5 plus 4 gives me 9 sine squared x. All right, and then f of x right here. All right, so they wanted us to put it in a nice format, and now we can use our pretty to solve. Okay, careful that +2 is on the inside with my function, so -4 plus 9 sine squared x plus 2 equals 0. Here is my domain. That 3 pi over 2, that's 270 degrees, okay? All right, add these two together. Actually, I'm just gonna move them both over here. So -2 and then +4 is gonna be a +2. So 9 sine squared x is gonna equal +2, divide by 9. I'm gonna go ahead and adjust the way this looks. Remember, that's just lazy notation. All right, so now we square root sine of x equals, don't forget, plus or minus the square root of 2 over 9. I suppose it would be acceptable for you to write the square root of 2 over 3. I just wouldn't if both the numerator and denominator are not perfect squares. So we are not required to do our x and y axis here because this kind of takes care of everything for that. So now we are... sorry. I forgot about our domain. Our domain was different. All right, so remember this is pi halves and this is 3 pi halves. So we are gonna have, if sine is positive and sine is negative, technically we would have answers in all 4 quadrants if we were going to 360 or 2 pi, but we're not. We're only going to 3 pi halves. So we're gonna have 3 solutions in quadrant 1, 2, and 3. Because this is where sine is positive, this is where sine is positive, and this is where sine is negative. But we're not going to concern ourselves with that quadrant because we have to stop here. All right. So for these first two, we are going to do sine of x is positive. So positive square root 2 ninths. Oh, goodness. All right. Radians, yes. Okay. Inverse sine square root 2 divided by 9. Make sure everything stays underneath the radical. All right, so this is going to be my first angle. X is 0.491. That's going to be this one. And then to get the other one, I do 180 minus that little bit. So that's going to be pi minus 0.491. So again, I'm not going to use the 0.491 because that's a rounded, so I'm just going to use what I have left in my calculator. Okay, so that's going to be 2.65 All right, so that takes care of my two positive solutions. And now, again, I'm just looking at my negative solution for that third quadrant. So sine x is equal to negative square root 2/9. Okay, so that is negative, 0.4908 or 491. It's just saying, again, same angle, same angle. I just going the opposite way. So this time I need to do 180 plus that positive version. So pi plus the positive version. Pi plus the positive version. So I'm going to go ahead and grab that one. And then 3.63. Okay, again, I stopped because of my interval. I don't go all the way. All right, it's almost there. Okay, number 12 is very similar to number 11, but this time we want to put our constant at the end. Okay, still trying to turn it into sine squared. All right, so 4 sine squared x, which means I'm going to convert that cosine into 1 minus sine squared. All right, distribute. Combine my like terms. It wants my sine term first, so I'm going to go ahead and make sure my sine squared term is first. That's a positive 9. Sine squared minus, forgot my x. Sine squared x minus 5. All right, now we need to solve. Okay, so here's this big guy. We're going from 0 to pi. Okay, so again, kind of like this one, we have a shortened interval. All right, again, use this little short guy. Use the nice one. 9 sine squared x minus 5 plus 1. Negative 5 plus 1 is negative 4. Moving it over turns it into a positive 4. 9 sine squared x divide. Square root. This one, both of those are perfect squares. So plus or minus 2/3. Okay, again, because both of those were perfect squares, it is okay for you to actually take the square root. All right, I'm going to do this little guy. Again, I'm only going to pi. Only go to pi. So I only want to know those two solutions. So I don't want the negative version because I'm only going to pi. All right, so I kind of ignore that negative. So inverse sine 2/3. Okay, here's my angle. So x is going to equal 0.7297 or 0.7. Sorry, I'm doing bad about rounding properly. Okay, so there's that one. So again, that's this angle right here. So to get it same angle in that third quad or that second quadrant, goodness gracious, I want the obtuse one. So I have to do pi minus this little guy. Pi minus 2.41. All right, you made it. Okay. I'm going to pull my test questions from these 12. I think there's probably going to be about 5 or 6 questions on the test, depending on how long it takes to solve. I will upload this key, and good luck, my friends. I will see you Monday.